and welcome to this week's episode of Lattes and Lingerie. My name is Ella Pierce, and I am the host of your every week's sleepover, as per usual. And today we're going to be talking about the very inspirational and awe-inspired quote by Carl Sagan. If you've never heard of Carl Sagan, not a big deal. Neil Tyson has been known to kind of spout out at the mouth about the same kind of phenomenon, and that is: the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. And an honorable mention goes to, if you wish to make an apple pie from scratch, you must first invent the universe. Also by Carl Sagan. But before we get there, in case you are unaware, I am a traveling boudoir photographer who was put on this planet by the all-knowing source to empower people of all varieties, and would love nothing more than to take sexy portraits of you while discussing all of the coolest things about being human, as well as some of the not-so-amazing things when necessary. Because we all know that it's not all easy having a big brain. For more information about that, go ahead and head to my website, which of course is going to be linked in the description, but is www.cherrytreeboudoir.com. And check out the cool shit that I have there, stuff like gallery, FAQ, about page. The about page is really great. I actually really love that page on my website. And while you're at it, make sure you grab the expose. Just click the expose tab, put in your email, and you'll have access to all kinds of stuff like advice about picking a wardrobe, as well as learning how to see yourself as a sex god. Plus, you'll get to see what it's really like. And of course, everybody's favorite topic is in there: pricing. So go to the link in the description and check it out all for yourself. Now that that's out of the way, today we're going to be talking about what the quote, "we're all made of star stuff," really means, and how it's not actually just philosophical, it's actually quite literal. But spoiler alert, I am not a cosmologist, and actually I don't even have a degree of any kind. I went to college, but I never finished because I realized that I was the only one who cared about the paper. So hopefully this will lure some actual scientists to kind of make sure that we're on the right track, and if not, kindly comment in the comment box down below where we can learn more if you're not able to spend the time to make sure we're getting it all right. We do our best here, and that is all that's required. So first we need to talk about what are stars, what are they made of, and what are their jobs. So stars are luminous, which means giving off light, and they're made up of mostly hydrogen and helium. I assume that y'all are familiar with helium, but here are some cool uses for helium that I didn't know about. You can use helium for lightweight vehicle fuel, of course, like balloons. Mixing helium with hydrogen makes it a lot safer, hence the Hindenburg. It has multiple uses in the medical field, like for treatment for disorders involving the lungs, like asthma and emphysema. And actually, MRI machines require liquefied helium. When the element is set at negative 269 degrees Celsius, which is only 4 degrees above absolute zero, this is the lowest boiling point for all the elements, it becomes usable in an MRI machine to cool a superconductive magnet. They also use it outside of the medical field to do the same thing. We'll talk a little bit more about that in a minute with hydrogen. It's also used in the same way of development for the components of titanium, silicon, and germanium. Never heard of that one, actually. It can also be used as rocket fuel. You can also use it with neon to read barcodes, which I thought was really cool because I've worked in retail for like my entire life. And dating for rocks that include uranium and titanium. So hydrogen is also very useful as life on Earth as a human being. And I'm not going to go into all of the uses for it because that would be obscene. But some of the top uses for it as a human being would be gas welding. It is used in this type of welding because it is able to increase temperatures up to 4,000 degrees Celsius. And it, like I said before with helium, it also acts as a shielding gas. Since metals at high temperatures are very reactive, hydrogen prevents them from reacting with other elements like nitrogen and carbon, which are of course very abundant in our Earth. Hydrogen fuel is a zero-emission way to fuel automobiles. I truly think that in the future, with the age of Aquarius, we're not going to be relying on individual travel the way that we do now, but in the meantime, it would be really cool if the oil industry would allow this to happen. Currently, it is being used for things like bikes as well as submarines, which I think is really sweet. They use hydrogen in petroleum refineries to remove sulfur, as well as in ultraviolet lamps. These lamps have a tungsten filament which heats up, excites the deuterium. Is that right? Deuterium? The deuteron atoms, which produce light in the ultraviolet region. Of course, you also know that hydrogen can be used in natural ways like making water. But what do they mean about stars being made of mostly hydrogen and helium? Stars actually have smaller amounts of all kinds of elements, all the way up to iron, actually, which is what scientists hypothesize that the majority of the planets are made of. Except for Jupiter and Uranus, all the other ones are hypothesized to have iron cores. Even Saturn and Neptune do, the big gas giants. But how did the iron get here? In fact, how did any elements get here? Stars actually have a couple jobs when you boil it down. Again, I am not a scientist. You are just listening to this for entertainment purposes. You are not writing a paper about what I'm saying, right? So one of their jobs is to be suns for planets. By the way, how many stars are there? Here is in all actuality and probability, an extremely gross underestimation of the amount of stars in the observable universe, which we have no fucking idea how big it is. We only, quote, know that there has been enough time for light to travel 13.8 billion light years. And that's only since the universe has expanded enough to allow light to travel in the first place. When it first started, it was all too dense. I mean, consider how crazy it is that it has been able to travel that far when it travels that fast. I mean, you're familiar with shadows and how shadows work, right? Anyway, the probably gross underestimation is 1 septillion stars. Now, I know that that means absolutely fucking nothing to you, so let me try to describe what a septillion is to you. So when you add 1 0, that's called 10. And it would be really cool to find a $10 bill on the street or in a coat pocket. When you add 2, that's 100. And that's a pretty nice gift from a parent or a grandmother, right? When you have 3 zeros, that's called 1,000. And that's a pretty nice weekly paycheck or a pretty average bi-weekly paycheck. When you add 4 zeros, that is 10,000. This is every influencer's monthly hashtag goals. When you add 6, that's called 1,000,000. This is every influencer's hashtag yearly goals. There are 48.5 million millionaires on Earth, just in case you thought that was a unique goal. When you add 9 zeros, that's 1 billion. And among others, Jay-Z is worth $1 billion. Apparently, he is the first person in hip-hop to be a billionaire, which I thought was very interesting. There are 2,150 billionaires on the planet, according to Forbes magazine. When you have 12 zeros, that is a trillion. That is, times 27, the U.S. national debt. When you have 15 zeros, that is a quadrillion. That is 1 million Jay-Z bank accounts. When you have 18 zeros, that is a quintillion. That is 18 million U.S. debts, or 1 billion Jay-Z bank accounts. When you have 21 zeros, that is a sextillion. That is 1 billion U.S. debts, and Jay-Z is becoming very irrelevant now. Now, when you add 24 zeros, that is a septillion, which is 1 trillion U.S. debts. If you hear this information and you still don't believe in aliens, you are in the worst denial I've ever heard of in my life. And you're being ridiculous. But yes, in most definitely, this is a laughably low estimation only because of the fact that this is just the observable universe. Especially when you consider the near positivity that this is a small section of the universe and most likely a small section of the observable universe of the multiverse. So that is one of the jobs of stars, to be the suns for other planets. Their gravity creates order in systems that revolve around them. They're called solar systems. You're probably familiar. You live in one too. We are living in one of countless solar systems. Even in our own Milky Way galaxy, there are estimates there are 200 billion stars. That's Jeff Bezos' net worth or 1 year of Amazon's revenue. This gives planets the ability to spend time evolving. Imagine how impossible it would be for life on Earth to evolve if we were just wandering about space and had no access to reoccurring cycles of light and seasons. This brings us to the other job of stars. Aside from their job as muses to poem writers and romantics of history past, which we are unfortunately not going to go into here. And it all revolves around gravity. So stars and suns are burning balls of gas that are suspended in space because of gravity. And the fabric of space and time is governed by one of the principal laws of the universe, gravity. And when gravity gets really intense, space and time begins to shift. And things aren't quite what they seem. But that's a story for another day, when we talk about black holes, white holes, and wormholes. Gravity is one of the 4 fundamental forces of nature, along with electromagnetism and the strong and weak nuclear forces, which we will talk about later. Funny enough, it's actually the weakest of all 4 because you can actually momentarily escape it by jumping, and you have no trouble raising your arm to get away from the center of the planet or getting up in the morning. Well, usually. In fact, the electromagnetic force between a proton and an electron in a hydrogen atom is 10 to the 40th power, which is 10 with 40 zeros behind it, times stronger than gravity. For large objects, though, gravity wins, because there is no repulsion, only attraction. The greater 2 objects' mass is, the stronger that the gravity is, and it is only reduced by their distance to each other. Yes, I know this is surprising, because if there is only attraction and no repulsion, then how come things don't fall into each other? Why doesn't the moon fall into the earth, and why does the earth fall into the sun? Especially Mercury, it's so small. Why isn't it just falling into the sun? It's so close. This is because of centrifugal force. This is the same force as if you put water in a bucket and then swing it around, and if you do that, the water will never fall out, even when it's upside down. Try this with a toddler. They think it's awesome. Newton's first law of inertia says that items that are in motion will stay in motion in the same direction and speed as long as no force acts upon them. But gravity is a force acting upon them. So when the orbiting body's centrifugal motion matches up with the gravity, it starts to orbit. So what does gravity have to do with a star's job? Well, stars are huge. They're some of the hugest items in the universe. Are they the hugest? I would say yes. Pretty much, unless you start counting things that are collections of things, like galaxies or nebulas. It's pretty likely that stars are the biggest thing in the universe. The sun is about 150 times larger than the Earth, and it has 98% of the mass in our solar system. And the sun is 333,000 times heavier than the Earth. The largest star that we've found is UY Scuti. And if we put it at the center of our solar system, its edge would go all the way through the orbit of Jupiter, and the dust field would go past Pluto. And if stars are huge, then that means that huge levels of gravity are going to be at play. But if stars are big balls of gas, then that must mean that something inside is fighting against the gravity. It's just a ball of gas after all. And inside of the sun, or any star, is a core, just like any spherical object in the universe. But in the sun, the core is made of hydrogen and helium instead of a molten metal like Earth, which is nickel and iron. Theoretically. Again, this is not something we can actually test. It's just a theory that that's true. Inside the sun, it is so hot with such high pressure that this becomes the perfect condition for nuclear fusion. And without getting into the chemistry too deep here, just imagine an atom. Little ball in the center, little electron, little ball flying around on the outside. Little ball in the center is called a nucleus, and the little ball on the outside is called the electron. In a hydrogen atom, the ball on the inside, or the nucleus, is a proton, and the one flying around the outside is an electron. And for anybody who remembers anything about high school chemistry, there are no neutrons in a regular atom of hydrogen. Truthfully, in the sun, it's actually hydrogen isotopes, which do have some neutrons, which makes it easier for them to fuse, but we can still run with this example to understand it theoretically. So nuclear fusion means that the pressure and temperature is so high that the protons are literally fusing together. And when 2 protons get together and hang out permanently, and they bring along their electrons, that makes helium. Now you have 2 protons and 2 electrons. This reaction is called fusion, but it's not to be confused with fission, which is what nuclear power is on Earth, and we've been doing that since about 1946. That's actually the splitting of a nucleus and is a different process. When this process occurs, there's an insane amount of energy released because they're actually overcoming 2 of the fundamental forces of the universe, the strong and weak nuclear forces, which are 2 of the 4, along with electromagnetism and gravity, like we said before. And this is where an intense amount of energy comes in the form of light, heat, and electricity. Fission only overcomes one of these, the strong nuclear forces. But this, mind you, is the force associated with an atomic bomb. So just imagine fusion at 3 to 4 times stronger. But what happens when a star runs out of hydrogen? Well, then it switches to fueling with helium. This is called the triple alpha process. I'll give you the short wiki version. Nuclear fusion reactions of helium atoms produces an unstable version of beryllium. This decays back super quickly, fractions of a second. Unless in that time another helium atom joins in. When they fuse, this creates a relatively unstable version of carbon. But once in about 2,400 times of this process happening, it will actually stay as a carbon. This is actually carbon-12, which is about 98% of all of carbon. So when a star runs out of hydrogen, it contracts a little bit and heats up more. This is the first time that gravity starts to win against the fusion. If the central temperature gets hot enough, about 6 times the temperature of our sun's core, then the helium nuclei can fuse fast enough to overcome this statistical beryllium barrier. And it will start to produce significant amounts of stable carbon, with a side order of photons and energy. Additionally, as a side effect, these stable carbons will start to fuse with helium, which will create stable oxygen, also with photons and energy. This happens over and over and over until the star eventually makes nickel, which decays into iron. And the iron nucleus is the most stable in nature. It neither fuses nor splits. But then how do the rest of the elements come? Because there are a lot of elements that are heavier than nickel and iron. After that, there are 2 processes called neutron capture. And one of them is the R process and one of them is the S process. The S process is slow capture and the R process is rapid capture. It would be extremely advanced to go too far down this path, especially because most of those elements are not really part of what it means for you to be made of star stuff, which is like 92% hydrogen, carbon, and oxygen. And that's kind of the point of today's podcast. But the main difference is that the slow process takes place over thousands of years, and the rapid process takes place in literally fractions of seconds. For the slow process that takes thousands of years, it actually happens in an environment where a supernova has occurred and left behind little iron seeds, we'll say. But how do these elements get spread around? After a star can no longer support itself because it's running out of elements, especially once it gets close to making only iron or nickel, it eventually collapses into itself. In very large stars, this becomes a supernova or a hypernova event. With incredible energy, it blows its material all across the universe. After this happens, the materials are quote unquote out there. And then it can be used by the universe in different ways, such as collapsing into planetary bodies or other stellar items such as stars or asteroids or comets. It's anybody's guess. After that, the remaining core will become one of 2 things depending on the mass of the star originally. It will either become a neutron star or a black hole, both of which are equally as cool, even though black holes are more popularized in pop culture. A black hole is so massive in such a small area of space-time that not even photons, which don't even have mass, I will remind you in case you didn't know, even they can't escape it. Ultra-large stars can create hypernovas, which can also turn into supermassive black holes. These have the ability to create entire galaxies that orbit around them, just like the Milky Way, which has a supermassive black hole in the center of it. And these keep galaxies in line, both literally and metaphorically. If it goes the route of the neutron star, then the mass of a sun goes into the size of a city block, basically 12 miles on average. That would mean that a sugar cube size piece of neutron star would weigh as much or more as Mount Everest. And here's a little trivia for you that I thought was super interesting. The name neutron star comes from the fact that all of the protons and electrons are smashed together so tightly that eventually they fuse and make neutrons, which have no charge. It's literally a chunk of neutrons. They also have the ability to spin at 500 revolutions per second, which is hella faster than any blender you have. But I digress. The reason that we're here is because we want to talk about the phrase, "You are made of star stuff." And while it's an extremely romantic notion, it's actually literally true. And in case you wanted some kind of recap, here's how it goes. Carl Sagan said, in order to bake a pie, you have to invent the universe. And here's what he meant. First, the Big Bang. Extreme amounts of energy, perhaps via fusion, at the center of a black hole. I sense another episode of a podcast coming on, but I digress. Transmuted into matter via the equation E equals mc squared, or energy equals mass times a really huge fucking number squared. So basically, some energy equals a fucking buttload of matter, mostly in the form of hydrogen atoms. Through Newton's first law of inertia, maybe, I don't know, like I said, I'm not a scientist, and after many years to a human, but only seconds to the universe, eventually items began spreading out. They started collapsing into planets and stars. Stars began producing heavier elements, then dying, and in spectacular events called super and hypernovas, began spewing their materials as far and wide as they could. Rinse, recycle, repeat, rinse, recycle, repeat. Eventually, the supermassive black hole at the center of the Milky Way galaxy collects enough space material to create its own galaxy. Eventually, the sun captures 98% of the mass in our neighborhood. Jupiter collects the remaining lion's share to help protect us by making the asteroid belt, and the rest of us planets split the remainder. Earth is formed, the moon protects us as well, we gain an atmosphere, suddenly we have a primordial soup, prokaryotes evolve to eukaryotes, which eventually evolve into fish that grow feet and walk onto land, then to mammals, and now we're complex and conscious enough to literally contemplate our own existence and how the fuck we got here. We are literally the universe contemplating itself and how it happened. Well, mind fucking blown, yeah? Like, that's probably the depth that I'm capable of explaining this at this point. But how amazing is it to recognize that you literally are from stars? I did include a ton of links down below in case you want to delve any deeper into this kind of stuff. I also recommend getting your own copy of the Oxford's Companion to Cosmology. Maybe they also have an astronomy one or maybe a planetary science one. I don't know. My copy's from 2008, which makes it ancient in the scientific community, but it's really fun. It's written like a dictionary, so you can just kind of rabbit hole deeper and deeper into any of these concepts or any of these particular items that you just need a little more knowledge into until after 5 terms, you're like, okay, do I understand that term 5 times ago? And you're able to kind of just go deeper and deeper into the black hole. If you know of anybody who might be interested in hearing this, then you should totally send it to them. And if you haven't, consider subscribing yourself. I have new episodes come out every Monday, and I'm available on quite a few platforms now. We're on Spotify, Anchor, YouTube, of course. My Instagram is starting to get really fun. It's young, but I can see where it's going. I can tell it's going to be stellar. Do you see what I did there? Anyway, thank you guys so much for taking the time to hang out with me today. If you want to check out my website, just go to cherrytreeboudoir.com. That's Boudoir. It is French. But anyways, I hope that you have a wonderful rest of your day, and make sure you leave a like and a subscribe and a comment and hit the bell and do all the things, and I'll see you next time. Later, Gator.